In this exercise, we're given two relations R and S. Our task is to draw the relations R and S, as well as a few other relations that are defined in terms of R and S. Let's start with R, and let's first look at the point A. Now, A is related to both itself and B by R. And B is related to only itself. And that's the relation R. S next. A is related to B, and B is related to A. And that's it. Next, let's move on to R inverse, the inverse of R. Now, X is related to Y by the inverse if and only if Y is related to X by R. So, to draw the inverse, all we need to do is flip the direction of each of the arrows in R. Note that if we flip the direction of the arrow from A to itself, it still points from A to itself, and likewise for B. So this is what we get for the inverse relation. Next, let's look at the complement of R. This will have all pairs of elements that are not related by R. So B is not related to A by R, so it's related to A by the complement. And that's it. All other pairs of elements are related by R. So this is the complement. Next, let's look at the union, R union S. This will have any pairs of elements that are related by either R or S. So we can start by drawing all the arrows that are in R, and then add any arrows that are missing that are in the relation S, in this case B to A. And that's the union. Next, let's look at the intersection, R intersection S. This will include all pairs of elements that are related by both R and S. For example, A is related to B by R and by S. So A to B is included. And that's it. A is related to itself by R, but not S. Likewise with B. And B is related to A by S, but not R. So none of these are in the intersection. So we're done with the intersection. Let's move on to the difference R minus S. This relation will include any pair of elements that are related by R but not S. For example, A is related to itself by R but not S, so that's included. And the same goes for B. B is related to itself by R but not S. A is related to B by R, but it's also related by S. So that is not in the difference. The difference is finished. And finally, let's look at this composite relation, R composed with S. To find what A is related to by this composition, we first need to look at what A is related to by S, and then what each of those elements are related to by R. So A is related to B by S, and B is related to just itself by R. So A is related to B by the composition. B is related to just A by S, and A is related to both itself and B by R, and so B is related to both A and B by the composition. And that's the composite relation. And we're done. In this exercise, we're given two relations, R and S. Our task is to draw R and S, as well as a few other relations that are defined in terms of R and S. Let's start with R, and let's first look at the number 1. What is 1 related to by R? Well, 1 is related to itself, and it's related to 2. Okay, next let's look at 2. 2 is related to just 3. And looking at the number 3, this is related to both 1 and 3 itself. And those are all the pairs in the relation R, so we're finished with R. Next, let's look at S, and let's start with 1. 1 is related to both 2 and 3. Next, what's 2 related to? 2 is related to just 1. And 3 is related to just itself. There's R and S. Let's move on now to R inverse, the inverse of R. Now, X is related to Y by the inverse of R if and only if Y is related to X by R. So in order to draw the inverse, all we need to do is flip the direction of each arrow in R. Note that when we flip the direction of the arrow from 1 to itself, it still points from 1 to itself, and likewise with 3 to itself. So there is the inverse of R. Next, let's look at the complement of R. Now, the complement of R is just any pair of elements that are not related by R. So, for example, 2 is not related to itself by R, so it is related to itself by the complement of R. And 2 is not related to 1 by R, so it is related to 1 by the inverse. 1 is not related to 3 by R. 3 is not related to 2 by R. And we're done there. That's the complement of the relation R. Next, let's look at the union of R and S. So this will have all of the pairs that are related by R, as well as all of the pairs that are related by S. So let's start by adding all of the arrows that are in R. And now we can add anything that's missing that is in S. So we have 2 is related to 1, and 1 is related to 3. And there we have the union of the relations R and S. Next up, the intersection of R and S. So So this will have any pairs of elements that are related by both R and S. Looking at the two relations, we see that 3 is related to itself by both R and S, and 1 is related to 2 by both R and S, and that's it, right? 1 is related to itself by R but not S, so that's not in there, and so on. There's the intersection of R and S. Next up, the difference R minus S. This will include all pairs of elements that are related by R but not S. So, for example, 3 is related to 1 by R but not S, so that's included. 3 is related to itself by R but also by S, so that's not included in the difference. 1 is related to itself by R but not S. And 2 is related to 3 by R but not S. And 1 is related to 2 by R but also by S, so that's not included. And we're done. That's the difference R minus S. Next, and finally, the composite relation, R composed with S. Now, to see what 1 is related to by this composite relation, we first see what 1 is related to by S, and then see what each of those numbers is related to by R. So first of all, 1 is related to 3 by S, and then 3 is related to both 1 and 3 by R. So in the composite relation, 1 is related to both 1 and 3. Now, 1 is also related to 2 by S, and 2 is related to 3 by R, and so again 1 is related to 3 by the composition, but we already have that. Let's move on to 2. 2 is related to 1 by S, and then 1 is related to both 1 and 2 by R, and so in the composition 2 will be related to both 1 and 2. And finally, let's look at 3. First, by S, 3 is related to itself, and then by R, 3 is related to itself and 1. So in the composition, 3 is related to itself and 1. And that is R composed with S. And we're done. In this exercise, we consider 3 relations defined on the set of natural numbers. The less than relation, consisting of all pairs x, y, such that x is strictly less than y. The less than or equal to relation, consisting of all pairs x, y, such that x is less than or equal to y. And the equals relation, consisting of all pairs x, y, such that x and y are equal. Now we are going to look at a few other relations that are defined in terms of these 3 relations. First up, the union of LT and EQ. Now for a pair of numbers to be in this relation, the union, it must either be in LT or in EQ. In other words, for a pair XY to be in this union, X must either be less than Y or equal to Y. So this is in fact the less than or equal to relation. Secondly, this is the intersection of the LE relation and the complement of the EQ relation. Now for a pair to be in this relation, it must be in both the LE relation and the complement of EQ. In other words, for a pair XY to be in this intersection, X must be less than or equal to Y, and X must not be equal to Y. So this is in fact the less than relation, LT. Finally, this is the difference, LE minus LT. So for a pair to be in this relation, it must be in LE, but not LT. In other words, for a pair XY to be in this relation, X must be less than or equal to Y, but not strictly less than Y. So this is in fact the equality relation, EQ. And we're done. In this exercise, we have three relations, L, E, and T, defined on four sets. The set S of students, the set R of student rooms, the set C of courses, and the set P of professors. Okay. Now L relates a room R to a student S if student S lives in room R. E relates a course C to a student S if student S is enrolled on course C. And finally, T relates a professor P to a course C if the course C is taught by Professor P. Now we want to describe these four relations, which are defined in terms of the three relations L, E, and T. So let's first look at E inverse. Now the first thing to note is that E maps the set S to the set C, so that E inverse maps C to S. Now, when is the pair CS in the relation E inverse? Well, this pair will be in the relation E inverse if the pair SC is in the relation E. And we know that that is the case when student S is enrolled on course C. So this pair will be in the inverse relation if course C is taken by student S. Now let's look at our second relation, E composed with L inverse. Okay, now remember that we first apply L inverse and then E. Okay, L maps the set S to R, so L inverse will map R to S, and then E maps S to C. So this composition will map R to C. Now when is the pair RC in this relation? Well, we'll see that R is related to an element S if student S lives in room R. And this element S is related to C if student S is enrolled on course C. So these two elements, R and C, are related if there is a student S that lives in room R. So if R is lived in by a student S who is enrolled on the course C. The third relation is E inverse composed with E. Okay, so we apply E first and then the inverse. E maps the set S to C, and the inverse will map it back to S. So this composition will map S to itself. Now, when is a pair of students in this relation? Right. So student S is related to an element in C if the student is enrolled on that course. Let's say course C. And then student T is related to course T if T is enrolled on that course. So these two students will be in this relation if student T is enrolled on a course that is taken by student S. Okay? In other words, if the students S and T are both enrolled on the same course. And finally, let's look at the composition T composed with E composed with L inverse. So the inverse of L will map the set R to S, then E will map S to C, and finally T will map C to P. So this composition will map the set R to the set P. Now, when is the pair RP in this relation? So R, room R, is related to a student S if that student lives in room R, and that student S is related to course C if that student is enrolled on course C, and that course C is related to Professor P if Professor P teaches that course. So room R is related to Professor P if a student living in room R is enrolled on a course that is taught by Professor P. And there we have our four relations. This exercise involves relations defined over the duck family. Our first task is to write out the four relations mother, brother, uncle, and nephew. So let's start with mother. Now, which pairs will be in this relation? Hortense is the mother of Donald and Della. So the pairs Hortense Donald and Hortense Della will be in this relation. And Della is the mother of Huey, Louie, and Dewey. So that's a further 3 pairs. So let's write this relation. Second relation is the brother relation. Now, Scrooge is the brother of Hortense, Donald is the brother of Della, and Huey, Louie, and Dewey are all brothers of one another. So let's write out this relation. There is the brother relation in full. Thirdly, we have the uncle relation. So Scrooge is the uncle of both Donald and Della, and Donald is the uncle of Huey, Louie, and Dewey. So this will give us 5 pairs in total. And finally, let's look at the nephew relation. Now, Donald is the nephew of Scrooge, and Huey, Louie, and Dewey are all nephews of Donald. So there is the nephew relation written out in full. Our final task of this exercise is to define the uncle relation in terms of the relations mother, father, and brother. Now, an uncle is just the brother of a parent, right? So we can define it as a composition of the parent with brother, but we must define this relation, parent. Now, a parent can be either a mother or a father. So to get this relation, we can simply take the union of the relations mother and father. Now it's very important to get the order of this composition right. Okay? We must apply the brother relation first and then parent, right? Since an uncle is the brother of a parent. Let's look at an example to highlight this. So we know that Scrooge is the uncle of Donald, right? And we know this since Scrooge is the brother of Hortense, and Hortense is the parent of Donald. Right? Hortense is the mother of Donald and therefore is a parent of Donald. This exercise involves the Corleone family. We will be defining a few relations on the set of Corleones. Now, our first task is to define the father relation in terms of the mother and husband relations. Now, in this family, the father is the husband of a mother. So this will be a composition of the two relations. And remember, we need to apply the husband relation first. So the order here is very important. For an example, Michael is the father of Mary. This is since Michael is the husband of Kay, and Kay is the mother of Mary. Our second task is to define the wife relation in terms of the husband relation. Now in this family, person X is the wife of person Y if and only if person Y is the husband of person X. And so this is an inverse relation. Thirdly, we want to define the relation spouse in terms of the relations husband and wife. Now, a spouse can be either a husband or a wife, and so this is the union of the two relations. And finally, we are asked to define the cousin relation in terms of the relations parent and sibling. Now, the cousin is the child of the sibling of a parent, and child can be defined as the inverse of the parent. So putting this all together, cousin can be defined by this composition, remembering again that order matters.